In our previous video lecture on complex numbers, we were just introduced to them. We talked about imaginary numbers, we talked about real numbers, and the fact that an imaginary number plus a real number is equal to a complex number. In this video lecture, our objective is to add, subtract, multiply, and divide complex numbers. Okay, what do we know? Well, we know what a complex number is from the previous video, as we just talked about. A complex number is a combination of a real number and an imaginary number. So 7 plus 3i is a complex number. The 7 is the real part. This is the imaginary piece, of which the 3, or the positive 3 in this case, is the imaginary part. Not parts, I misspelled, and the I is the imaginary unit. Okay, now one thing I want to point out, when you see a plus bi, that's the standard form of a complex number, a plus bi. So the real part plus the imaginary part with the imaginary unit at the end. Okay, adding. Fairly straightforward. To add two complex numbers, we add each part separately. So a plus bi plus c plus di, one complex number plus a second complex number. We add the real parts, we add the imaginary parts, and then we attach on the imaginary unit. So here we have, let's do an example. 3 plus 5i. My 5 is a little sloppy, sorry about that. Okay, the complex number 3 plus 5i, I want to add that to 4 minus 3i. Okay, so let's see here. 3 plus 5i plus 4 minus 3i. Okay, I'm going to add the real parts. So 3 plus 4, those are the real parts. And I'm going to add the imaginary parts. So 5, and I'll write it down as 5 plus negative 3. But I'm sure, as you know, 5 plus negative 3 is the same as 5 minus 3. And then we have an I. Okay? 4 plus 3 is, whoops, let's put an equal sign here. 4 plus 3 is 7. And 5 plus negative 3, or 5 minus 3, is 2. And then there's the I. 7 plus 2i. Okay? Let's take a look at that with our calculator, which can do this for us. Okay. Let's see if I'll pull this. It won't work. I'll pull this over here to this side. I think I can get it in there that way. Okay, so as you know, our imaginary number, the letter I, is the key above the, I'll slide this up here. It is a second function above the decimal down at the bottom down here. There's your I right there. So we need to use our blue key here, and then to come down and press the decimal button to get the I to come up. Okay, so let's make sure you can see all of this. I think that works. Okay, turn it on. Let's see here. 3 plus 5i. I'm going to use parentheses just because I think it kind of makes sure that you know the numbers are, this is one complex number and then the second complex number. I don't think it matters, but I'm going to do it anyways. 3 plus 5, second key to get the I. So there's 3 plus 5i. And I want to add that to, I'll use parentheses again, 4 minus 3i. 4 minus 3. And there's the I, and I'll press enter, and there you have it, confirming it's 7 plus 2i, just like we have here. Okay, let's talk about subtracting complex numbers, and it's not a whole lot more complicated. To subtract two complex numbers, well, first distribute that negative or that subtraction sign, and then add. So a plus bi, one complex number, minus c plus di, a second complex number. Well, a minus c, the negative sign, the minus sign distributes. A minus c, that's the real part. B minus d, That's the imaginary part, and then there's the I. Okay, so let's take a look at our example. I want to subtract the complex number 2 minus I from the complex number negative 6 minus 3I. Okay, so I have negative 6 minus 3I, and I want to subtract this from that. So I'll subtract 2 minus I, and we know that we can look at that and say, okay, whoops, I'll tell you, we'll do this over here. We're going to distribute that negative. Let's do it over here. So I'm going to say this is negative 6 minus 3I. So I'm going to put a plus here. I'm going to distribute the negative, so I have a negative 2. This is kind of an extra step. You may be able to get without doing this, but I'm just going to show you this kind of extra step. Obviously, this is going to be minus 2, which is plus a negative 2, minus a negative I is plus an I. So now we have an addition situation. Okay, well, we add the two real parts, so negative 6 plus negative 2. We add the two imaginary parts, negative 3 plus 1, and then there's our I. And we're left here, well, negative 6 plus negative 2 is the same as negative 6 minus 2, and that's negative 8. And then we have negative 3 plus 1 is negative 2, so minus 2I, and this is in standard form. Okay, let's do a quick check. Why not while we're here? Let's see if I'll put this right below. That should fit on the screen here. I want to focus on this right here in my calculator. So parenthesis, negative 6 minus 3I, subtract, parenthesis, 2 minus an I, and I come up with negative 8 minus 2I, which is exactly what I came up with here when I did it by hand. All right, moving on to multiplication. Multiplication of two complex numbers, as you can imagine, because the complex numbers both have two parts, they look a bit like binomials. So we're going to FOIL. We're going to do first, outer, inner, last. We're going to treat them as if they're two binomials, which you saw in algebra, or maybe algebra 2, depending upon your school. Okay, so the complex number a plus bi times the complex number c plus di is equal to, well, a times c plus a times di. So first, outer, so the a is done. I've distributed the a to both. Okay, now I'm going to distribute the bi to both. So bi times c and bi times di, which gives me bdi squared. Okay, so there's multiplication. Now we want to remember something. We're going to need to remember from our previous video that I squared is equal to negative 1. Okay, that's going to come into play right here. We know what I squared equals. I is equal to the square root of negative 1. So I squared is equal to negative 1. That's a kind of a fundamental fact you need to remember. So let's multiply in example 3 here. Let's multiply 3 plus 2i times 1 minus 7i. Okay, so 3 times 1 is 3. Positive 3 times negative 7i is negative 21i. Tell you what, let me come down so I can put my arrows down below. I forgot about a little bit of spacing here. Let's try that again. Okay, positive 3 times positive 1 is 3. Positive 3 times negative 7i is negative 21i. Positive 2i times positive 1 is positive 2i. And positive 2i times negative 7i is negative 14i squared. 2 times negative 7 is negative 14. I times I is I squared. Okay, now we start doing some simplification. Okay, I'm going to first address this. So I'm going to copy 3 minus 21i plus 2i. Of course, you could combine those. You'll probably get quicker as you get good at it. But let's remember, okay, I squared equals -1. So this is a -1 here, and a -1 times a -14 is a positive 14. Okay, so subtracting 14i squared is subtracting 14 times -1. And subtracting 14 times -1 is the same as adding 14. And now we can combine like terms. My constant term, the real number part, is 3 plus 14, and that's 17. And then the imaginary piece, -21 and 2, I hope is -19i. Okay, let's check it. So I'll slide this up a little bit. I'll put my calculator in here. Hopefully you can see it. I'll come over just a little bit just in case. Okay, let's do this and see if we get the same answer here. Open this up. So my first one is my first complex number, 3 plus 2i times 1 minus 7i. I'll press enter. 17 minus 19i. I got it. Worked out just fine. Okay, well, I'm going to do another multiplication example. Okay, I'm going to do, I think I got enough room on my paper, on this sheet anyways. Example 4, what is 1 plus I, the quantity squared? Okay, what's 1 plus I squared? I'll come up a little bit. Well, 1 plus I squared, as we know, let's expand that. That means 1 plus I times 1 plus I. To square means to expand it, multiply it by itself. Okay, well, +1 times +1 is 1. +1 times +I is I. So I've now distributed the 1 over these two terms. +I times +1 is +I. +I times +I is +I squared. So I'm here. Okay. Well, I'm gonna take care of the square first. 1 plus I plus I. Well, I squared. Remember, I squared equals -1. So that's going to be -1. If I squared is -1, then adding -1 is -1. Let's combine like terms. 1 minus 1. Well, that's 0. I plus I is 2i. And so there's your answer in standard form. Note, standard form requires this, in this case, it requires this 0, because standard form requires an A and a BI. So I didn't have an A, I didn't have a real part because I had 1 minus 1, but I do have a real part, it's 0. I just don't, I don't have it when I subtract, I get nothing, and normally we leave that, but we want standard form, so we're going to put the 0 in to note that it's there and it's in standard form. Okay, so that gets us through 3 of the 4. Let's talk about division. Get my notes together here. Okay, division is a little bit more complicated, but not too bad. To divide two complex numbers, we're going to multiply the numerator, and the denominator by the conjugate of the denominator. Okay, great. What's the conjugate? Well, the conjugate is the same two terms with the opposite sign between them. And that's going to require a couple of examples, I know, because it doesn't make a lot of sense to me either. Okay? However, you've seen this probably in Algebra 2 class. Okay? You've seen this when you've rationalized the denominator. Okay, so let's take a look. Okay, so the conjugate, the same two terms with the opposite side between them. So here's the example from maybe an Algebra 2 class. Rationalize denominator of 6 over 2 plus root 2. So rationalizing the denominator, in this case, the denominator is irrational because there's a square root of a prime number in the denominator, and we want the denominator to be rational. We don't want that square root of a prime. Okay, the way we do that is we multiply it So here's 2 plus root 2. We multiply it by the conjugate. Okay, the number 1 as the conjugate of the denominator, and we do the same thing to top and bottom because we're multiplying by a 1. So the same two terms with the opposite sign between them. So if we have 2 plus root 2, the conjugate, whoops, I wrote the wrong number. The conjugate is 2 minus root 2. If you're given 2 plus root 2, the same two terms, 2 and root 2, with the opposite sign. This is the conjugate. And of course, if we multiply numerator and denominator by the same thing, well, that's just 1. Something divided by itself is just 1. So we're not changing this. We're multiplying this by 1. We're not changing the value of it. We're just going to change the look of it. Okay, well, this, as you know, equals, well, let's see. This is going to be, I'm going to write this out. This is 6 times 2 minus root 2. I'm just going to rewrite it with parentheses. Divided by 2 plus root 2 times 2 minus root 2. So I didn't do any math. I just rewrote this without that dot using parentheses. Okay, now let's distribute. Okay, let's see here. Okay, so this is the numerator. Positive 6 times positive 2 is positive 12. Positive 6 times negative square root of 2 is minus 6 square root 2. Denominator, and this is where the conjugate comes in handy. Positive 2 times positive 2 is 4. Positive 2 times negative root 2 is negative 2 root 2. So I've distributed the positive 2 here. Now I'm going to distribute the positive root 2. Positive root 2 times positive 2 is positive 2 root 2. Maybe you can see already these are going to drop out because when we add them, they are opposites. They'll be 0. Positive root 2 times negative root 2 is negative 2. And so in multiplying by the conjugate, I have rationalized the denominator. I have no more radical sign in the denominator. Let's take a look. The numerator stays as it is, 12 minus 6 root 2. The denominator, well, negative 2 root 2 plus 2 root 2, that's nothing. Those two are 0. So I have 4 minus 2, and that's 2. Oh, I just rationalized the denominator. It's no longer irrational. And we can simplify this. This 2 denominator applies to the 12 and to the 6 root 2. And so this is the same as 6 minus 3 root 2. So you've seen this previously in some algebra classes. Okay? So let's talk about the conjugate of a complex number. Okay, so the conjugate of a plus bi, okay, well, we're going to keep the two terms the same and we're going to change the sign in the middle, is a minus bi. And if we have a minus bi, the conjugate is a plus bi. So, division, which was the topic at the beginning of this. Whoops, let me get my paper up. Oh, I lost you a little bit here. Sorry about that. The conjugate of a plus bi is a minus bi. So division. A plus bi divided by c plus di. We're going to multiply the numerator and the denominator by the conjugate of the denominator. Well, the denominator is c plus di, so the conjugate in this case is c minus di. And we'll multiply numerator and denominator by that because this, of course, is multiplying by a 1, and multiplying something by 1 does not change its value. Okay, let's take a look at a couple of examples. This is a little bit more difficult than adding and subtracting, as I'm sure you can tell. Okay, example 5. Let's do 2 plus 3i divided by 4 minus 5i. Okay? To divide, we're going to multiply the numerator and the denominator by the conjugate of the denominator. So, 2 plus 3i divided by 4 minus 5i. We're going to multiply by the conjugate of the denominator. So the two terms stay the same. The minus becomes a plus. 4 plus 5i, numerator and denominator. And again, something divided by itself is 1, so this being multiplied by 1 doesn't change its value, but it will change how it looks, which is what we're after. Okay, I'm going to rewrite this with parentheses. So 2 plus 3i, 4 plus 5i using parentheses. Okay, and the denominator, 4 minus 5i, times 4 plus 5i with parentheses. Now, let's go back to here. Remember something. Okay, we noticed here when we multiplied the denominators, we multiplied the denominator by its conjugate, a piece of this fell out. The middle piece fell away. Okay, we came up with this negative of something and the positive of the same thing, and so that went away. Think about what might be going away this time. The same kind of thing is going to wind up happening. All right, let's take a look. Okay, so we know, let's do the numerator. Positive 2 and positive 4 is 8. Positive 2 and positive 5i is 10i. Positive 3i and positive 4 is positive 12i. Positive 3i times positive 5i is positive 15i squared. We need to note the I squared because that's negative 1. Let's go to our denominator. Positive 4 times positive 4 is 16. Positive 4 times positive 5i is 20i. Negative 5i times positive 4, hey, check that out. Negative or minus 20i, that's going to disappear. And then negative 5i times positive 5i is negative 25i squared. Okay, so let's continue. I'm going to take care of this I squared in the numerator. So I have 8 plus 10i plus 12i. I squared is negative 1. Negative 1 times 15 is negative 15. Okay, and we can work with the denominator pretty quickly. Okay, well, it looks, again, these two middle terms are 0. Okay, so we have a 16. I squared is negative 1, and negative 1 times negative 25 is plus 25. Okay, so here we're remembering, I squared is equal to negative 1. Okay, let's clean it up. 8 minus 15 is negative 7. So that I'm working on the numerator right now. 10 i's and 12 i's is 22 i's. I'm going to divide that. Well, this is pretty simple. 16 plus 25. I believe that's 41. Okay, and we want to put it in standard form. Standard form means the denominator needs to go to both, so we have a real unit and an imaginary unit. So this is negative 7 over 41. The 41 under the negative 7. And then the 41 also goes to the 22. So 22 over 41 times I. And this is in standard form, which we're looking for. Let's check with our calculator. Okay, let's see it. Obviously much easier. Let's see if we get the same thing. Now I have a fraction bar on my calculator, so I'm going to use it by accessing it here, and you can see I have a fraction set up right there. Numerator 2 plus 3i. Denominator 4 minus 5i, and I haven't tested this, so I'm curious to see what's going to come out. Enter. Sure enough, It gives it to you in standard form, negative 71/41 plus 22/41 times I, right there. Okay, we'll do one more example, as I know this can be a little bit confusing for some. Let's get my paper straightened out, I think. Where am I on this thing? All right, I think I got you where I want you. Okay, my last example. Whoops, the example number 6. What is 5 minus I divided by 2I? Okay, well, you'll notice the denominator is a purely imaginary. It's not a complex number. It's a purely imaginary number. We're going to want to rewrite this so we can see how this works. We're going to want to rewrite this so that we can have a conjugate. And this is 0 plus 2I. So 5 minus I, the numerator is the same, but 2I as a complex number is 0 plus 2I. Oh, now I can multiply. Now I can find the conjugate. The conjugate is 0 minus 2I, and I can multiply numerator and denominator by the conjugate. Okay, so we're off and running. I'm first going to use parentheses just to rewrite it so that I can, a little clearer to me. You can do it without all of this. 0 plus 2I times 0 minus 2I. As you know, we're going to wind up dropping something in there. Okay, let's see here. So 5 times 0 is 0, minus 10I, plus 0, plus 2I squared. Hope I got that right. 0 minus 10I, 0 plus 2I squared, divided by 0, 0 plus 0 plus 0 minus 4I squared. Oh, that really fell out pretty fast, all those zeros in there. 0, 0, 0, negative 4I squared. Okay, let's take care of those I squareds. I got negative 10I. I squared is negative 1, so this is minus 2. And here, I squared is negative 1, so this is positive 4. Let's clean it up by putting the real number part in front. So it's negative 2 minus 10I over 4. Now let's put it in standard form. So the 4, let's first do the 4 under the 2, so it's negative 1/2. And now under this, let's say minus, well, this is, both of those have a common factor of 2, so how about 5/2 times I? Okay, so this is negative 2/4, which is negative 1/2. This is negative 10/4, which is negative 5/2 times I. So there you have another example. This time when you have a purely imaginary denominator, you're going to want to create a complex number so you can find the conjugate. So there you have it. Lots of work on working with complex numbers and the 4 operations.